Next we're going to talk about angles formed by parallel lines cut by a transversal. In class we talked about this a little bit, so if in the first two examples we actually cover that in class, feel free to just see if you can answer the questions. The first thing that we did in class is we talked about parallel lines cut by a transversal. Just as review, M is our transversal and L is parallel to N. When this happens, we form different angle pairs. So I decided to set a different orientation of parallel lines so that you could try to find the corresponding angles, the alternate interior, and the same side interior. Just as a reminder, corresponding means that they are in the same place. So if I look at angle 1, it's clearly in the same place as angle 5. Angle 2 is in the same place as angle 6, 4 is in the same place as 8, 3 is in the same place as 7. And so that's what we come up with as our corresponding angles. Alternate interior, same side interior all include what's inside. What's inside lines N and line L. Remember, alternate means that they're the opposite ones. So that's 4 and 6 and 3 and 5. And same side means not that they're supplementary. Just like 4 and 3 here, they're supplementary, they're a linear pair. But same side interior means something different. They're not separated by a ray. Now, I didn't go through all the different types, but we will see the other different types as we go through our problems. We also learned that when we have parallel lines, we can find all of the missing angles if we know that the lines are parallel and it's got a transversal, and we know one angle. So I already gave you that angle 4 is 115. So what we want to do is we want to fill in all of the other angles. Well, I know that 4 corresponds with 7, so that works. I know that angle 3 is vertical to angle 4, so that's also 115. And I know that 6 is vertical to 7, so that's also 115. Since angle 4 and angle 1 make a 180-degree angle, I know I can do 180 minus 115 to find what's missing. And what's missing is 65 degrees. So that means all of the other angles are 65 degrees. Now with those first two examples, that's what you will see on 8th grade MSA. But now we want to take it to the geometry class level. We're going to be taking a look at some equations to find missing angles. The 3 steps we're going to follow are the ones that are written right here. First, you're going to figure out what angles you see. Are they corresponding? Are they same side exterior? What are they? You're going to write an appropriate equation. Remember, the angles are either congruent or equal, or they add up to 180, and then we're going to find all the angles. Just a couple notes, in every diagram I do need to tell you that line U is parallel to line V. And I used this website, kudasoftware.com. They have some sample questions that you can use as well if you want to use that as a resource. So in our first diagram, we're given two angles, 12x minus 4 and 10x plus 10. So the first question we need to answer is, what type of angles are we looking at? Looking at the picture, those two angles are in the same place, so they are corresponding. If they are corresponding, then I know that the angles are equal. So when I write my equation, that would be how I set it up. 12x minus 4 equals 10x plus 10. Pause the video and solve for x. Once you've solved for x, you should have found out that x equals 7. What we're going to do next is we're going to find every single missing angle that's in this picture. So we need to plug in 7 to one of the angles. Not wanting to work super hard, I'm going to pick the angle 10x plus 10. And I'm going to plug in 10 to that. When I plug in 10 to that, I find 80 degrees is the angle here. And since it corresponds here, that works as well. Just like the last problem, we know this is 80, we know that this is 80. The only missing angle that there could be is 100. So by solving the equation, I was able to find everything missing in the picture. For this next one, we have decided we're looking at alternate exterior angles. They're opposite outside. Pause the video and see if you can answer all of the other questions on your own. In about 5 seconds, I'm going to go ahead and go through the steps. So the equation I wrote, because they're the same, is x plus 112 equals 105. Now don't be alarmed. When you solve, you can get a negative number for x. Just remember that the angle is not negative. In fact, we already know that both of these angles are 105 because it explicitly told us that. That means the other angle is 75. So this is 105, this is 105, 105, 75, 75, 75, 75. For our last example, this picture, I'll warn you ahead of time, is not drawn to scale since I wrote this question myself. I just used the picture from CUDA software. So we need to decide what types of angles we're looking at. Both angles are on the outside, but unlike the last problem, they're not opposite. They're on the same side. So these are called same side exterior angles. Just like same side interior angles, they equal 180. So go ahead and try to write an equation for this and pause the video, and in about 5 seconds I'll show you the equation I wrote. So I put together 8x plus 26 plus 10x plus 10 equals 180. Pause the video again and solve the equation for x. When I combine my like terms, I come up with this. When I finish solving, I come up with that x equals 8. Now, if I want to find all the angles and x equals 8, look at what happens. If one of these is 90, then that means all of the angles are 90. So every single angle in the entire diagram is 90 degrees. In class tomorrow, we're going to take a look at practicing some more of these equations and identifying what angle pairs we're looking at. And then the following day, we'll talk about how to take this information and write proofs with it.